Welcome to the debate. Imagine a striker making this blind, sprinting run into the channel in the 89th minute of a tied match.
Right, just pure exhaustion at that point.
Exactly. As fans sitting in the stands, we see raw desperation, we see passion. But what does an artificial intelligence system see?
Math. It just sees math.
Yeah, it sees a mathematical shift. It registers a sudden change in geographical proximity, calculating speed vectors and, geometric disruption in real time. So today, we are asking a fundamental question. Can an algorithm actually understand the beautiful game?
And that is exactly the tension we're seeing in the sport right now. We are moving away from a traditional model where a coach simply trusts their gut on the touchline.
Yep.
And we're moving toward an era where performance analysts are using algorithms to map out literally every single variable on the pitch.
Right. And today, we're digging into a massive new systematic review that looked at over 2,500 published articles on how artificial intelligence is being used in football analytics.
A massive pool of data.
Huge. But the researchers filtered all of that literature down to just 32 highly rigorous studies to figure out where the technology actually stands today. And while my position is that AI methodologies, from neural networks to advanced graph theory, have entirely revolutionized match analysis. We have entered a 3.0, maybe even a 4.0 level of objective analysis that gives coaches unprecedented, real-time decision-making support.
Well, and I will argue that while these mathematical models are brilliantly sophisticated on paper, the sheer amount of research that had to be thrown out to find those 32 valid studies tells a very different story.
You think it's overblown?
I think these tools are still highly theoretical. They map data points beautifully in a lab, sure, but they struggle profoundly to translate into true coaching realities on the grass, especially when you start looking at the ethical limits of treating human players like data nodes.
To understand the sheer scale of the shift we are talking about, you have to think about how football has been analyzed for the last few decades. It was incredibly subjective.
Oh, absolutely.
You relied on a coach's memory of the match, or maybe you had some static event data, like how many passes were completed or shots on target. It was essentially just counting things.
Right, it was an accounting exercise, basically.
Yes. But now, as these 32 studies highlight, we have continuous spatial temporal tracking. And if you're listening to this and wondering what that actually means, it means we aren't just looking at the player with the ball anymore. Cameras and sensors are tracking the exact X and Y coordinates of all 22 players.
Plus the ball.
Plus the ball, exactly, 25 times a second. To process that massive mountain of data, analysts are using convolutional neural networks, or CNNs. You can think of a CNN as an algorithm trained to understand spatial relationships.
Like analyzing an image frame by frame.
Precisely. Then they combine that with recurrent neural networks, RNNs, which process sequences over time.
Like a flipbook.
Right. By putting those together, we can decipher tactical patterns that the human eye simply cannot process all at once.
Look, I don't disagree that the computational power is staggering. It is. But I really...
In the farthest reaches of space, one scientist refused to stop searching. Every discovery uncovers The Scientist Explorers. Available now, just $4.99 on Amazon Kindle Unlimited. Start the adventure today.
Look at the systematic review's starting point. Over 2,500 articles. To find studies that actually prove their AI worked, researchers discarded the overwhelming majority of them. Why? Because algorithms are incredibly demanding.
Well, they require clean data.
They require perfect, rigid data structures. When a performance analyst looks at a pitch control map generated by an AI, we have to remember we are looking at an abstraction. We are mapping where a player is and how fast they are moving. We are not mapping the living, breathing, psychological reality of a football match.
But
human beings constantly defy probabilistic logic.
Let's pause on that idea of abstraction, because I think calling it an abstraction does a massive disservice to how these models actually function. Let's break down a pitch control map.
Okay.
For the listeners, Imagine laying a digital grid over the entire football field. At any given millisecond, the AI calculates exactly which team will reach each specific square foot of grass first.
Based on speed and trajectory.
Right, but it doesn't just look at where players are standing. It factors in player momentum, acceleration, even the friction of the pitch. It is a dynamic, predictive surface.
It is predictive based on physics, yes.
But it goes deeper than just physics. The literature dives into how AI utilizes advanced graph theory. Think about how Google uses the PageRank algorithm.
To rank websites. Exactly.
Google figures out which website is the most important based on how many other sites link to it. These studies apply that exact same concept to a football team's passing network.
Right.
They use metrics like betweenness centrality, which is just a fancy way of saying the algorithm identifies exactly which player acts as the critical bridge between the defense and the attack. It is essentially giving us a real-time neurological scan of a team's strategy.
A neurological scan.
We are literally mapping the nervous system of how a squad coordinates. How can you deny the utility of that for an analyst?
I love the neurological scan metaphor, truly. Because a brain scan can show you which neurons are firing, it can light up on a monitor to show activity, but it cannot tell you what the person is dreaming about.
Oh, come on.
No, really. AI in football is exactly the same. It shows us the firing neurons, the passes, the positioning, but it doesn't understand the tactical intent.
You don't think tactical intent can be mathematically modeled?
Not reliably, no. Look at how these models handle complexity. The review highlights techniques like TSNE and principal component analysis, or PCA.
Dimensionality reduction?
Exactly. To put that in plain English, these are dimensionality reduction techniques. You take massive, chaotic data sets with thousands of variables, and you have the computer squash them down into a 2- or 3-dimensional map so a human analyst can actually look at it and spot patterns.
Which is a brilliant way to make highly complex data readable.
Brilliant for computer vision, absolutely. But in doing so, you inherently strip away the chaotic nuance of the game. You force the algorithm to group things together that just look statistically similar.
I wouldn't say forced on.
But tactical football is fundamentally about deception. Think about your favorite striker. They might make a sprinting run out wide into the channel. Why? Often it's not to receive the ball.
It's a decoy run.
It's entirely a decoy run meant to drag a center back 2 yards out of position, creating a pocket of space for a midfielder arriving late. An algorithm squishing data down just sees geographical proximity and speed. It cannot encode the tactical intent of a decoy run.
Well, it measures the result.
It just sees a player running into empty space and not getting the ball. It gives analysts this mathematically beautiful illusion of understanding.
I have to push back there because the newer AI models do exactly that. They don't just say, player X ran here and didn't get the ball. They calculate the systemic impact of that run. This is where something called expected possession value, or EPV, comes in.
EPV is fascinating, but it's still just a probabilistic guess based on historical data.
It is a highly educated calculation. Let me explain how it accounts for your exact decoy run scenario.
Please do.
EPV looks at the current location of the ball, the positioning of all 22 players, and calculates the mathematical probability of that specific possession ending in a goal. Let's say if you pass the ball sideways, there's a 2% chance of a goal. If you pass it forward, maybe it's 8%.
Okay.
When your striker makes that decoy run, a well-trained pitch control model instantly registers the shift. It sees the defender get dragged away, it sees the spatial footprint of the defense warp, and the EPV of that newly opened pocket of space spikes tremendously.
Because the space is now dangerous.
Exactly. The algorithm doesn't need to pull the striker aside and ask if it was a decoy. It measures the resulting systemic vulnerability of the defensive structure in real time. The intent is proven by the mathematical outcome.
The intent is guessed by the mathematical outcome. And this brings us right to the problem of methodology, and really, the illusion that this technology is ubiquitous.
How is it an illusion?
You are speaking as if these AI systems are flawlessly running in real time on the touchline for every club every Saturday. But let's look at the actual rigor required by the review. To even be included, the researchers threw out anything that wasn't perfectly pristine. We're talking about incredibly strict quality scoring requiring an agreement rate among scientific observers of something like 96%.
Exactly. They separated the absolute signal from the noise. They didn't let flawed studies prop up their conclusions.
It's a great thing for academic publishing, but it is a massive red flag for practical football. Studies that looked at isolated physical performance without tactical integration, or studies lacking perfectly clean, comprehensive datasets were excluded entirely. What does that tell us?
That bad science was ignored.
It proves that AI in football currently works beautifully in sanitized, carefully curated datasets examined on a Wednesday afternoon in a quiet university computer lab.
I wouldn't call tracking data from professional matches sanitized.
But the conditions under which it's analyzed are completely sterile. Real-world matches are full of incredibly messy data. You have occlusions in the camera feeds where players block each other from the lens.
Sure, tracking errors happen.
You have unpredictable weather, a sudden downpour completely altering the physics of the ball and player acceleration. You have tactical shifts happening dynamically because a player got a yellow card. The massive exclusion rate in this review suggests these algorithms are incredibly fragile when exposed to the unpolished reality of the sport.
I hear what you're saying, but I look at that exact same exclusion rate and draw the opposite conclusion.
Really?
Yes. The strict filtering is exactly why we should trust these findings. This review wasn't just some loose aggregation of theoretical papers. It was a highly filtered distillation of empirical truth. The fact that they required such high methodological scores ensures that we are only looking at empirically sound evidence.
But evidence of what, exactly?
Evidence that these models actually work. Take random forest classifiers, for example. For our listeners, imagine a random forest as 1,000 tiny, independent computer models all voting on what the most likely outcome of a pass will be.
Right.
The evidence confirms that these tools can effectively map 3D ball trajectories and generate highly accurate pass probability models. The exclusion of lower quality studies doesn't mean the AI is fragile. It means the scientific method is doing its job. We are in a burgeoning field, and these 32 studies are the foundational pillars proving that complex data models can and do capture the reality of the sport.
I won't argue that the science is rigorous within its own vacuum. The math works, but my main contention is the bridge from that academic vacuum to the actual dugout. And this is exactly where the dynamic between the data-driven performance analyst and the human coach becomes critical. And honestly, quite fraught.
Okay, let's get into that.
The review explicitly points to severe challenges for the real practical application.
Right, it mentions a lack of cross-disciplinary professional profiles.
Yes! You can build the most robust pass probability model using a recurrent neural network, but who interprets it? Right now, we have a massive disconnect between the performance analyst and the coach.
They speak different languages.
Exactly. The analyst sits behind a screen, looks at a dimensionality reduction map, and sees a dip in a team's clustering coefficient. They walk into the manager's office and say, "The data says our spatial efficiency in the midfield is failing."
Which is valuable information.
But the coach looks at the pitch and sees a squad that is physically and mentally exhausted from a midweek away fixture in the rain.
But you know, if you're listening to this and wondering why a coach can't just use their eyes, it's because human context is notoriously flawed. Those two observations, the analyst's data and the coach's intuition, they should not be clashing. They are complementary.
They should be, but in practice, they often represent entirely different philosophies.
When the data analyst provides objective proof of a drop in efficiency, they are removing the guesswork. If a coach believes a certain pressing trigger is working, the AI-driven tactical behavior mapping can objectively verify if team possession patterns actually improved. It takes the subjective bias out of player development.
I'm not sure it does.
A player or a coach can argue about effort or intent, but they cannot argue with a deep learning algorithm that accurately models their spatial inefficiency over a 90-minute period.
I'm sorry, but I just don't buy that. And you just touched on something that hits at the core of the ethical limits discussed in this literature. We really need to unpack the ethics here.
Ethics of a pitch map?
You just said a player can't argue with an algorithm.
Because the tracking data doesn't lie. X and Y coordinates are objective facts.
The coordinates are facts, yes, but the algorithm's judgment of those facts can be deeply flawed. And we are talking about the ethical limits of applying data analysis to human beings.
Let's look at it from the perspective of a coach versus a performance analyst.
Okay.
From a coaching perspective, player management requires empathy, context, and understanding the psychological state of an athlete. From the perspective of a purely data-driven performance analyst, a player is reduced to a node in a graph theory metric.
That's a bit extreme.
Is it? We are harvesting their spatio-temporal tracking data, their biomechanics, their micro-movements, digitizing all of it through neural networks, and creating algorithmic judgments on their professional worth.
I think you're slightly sensationalizing the process. It is performance analysis. That concept has existed since the dawn of professional sports. We used to use stopwatches and notepads to judge players. Now we use AI models. We're just using a sharper lens.
It is fundamentally different when the lens is an impenetrable black box. Think about it from the dugout. If an incredibly complex machine learning model predicts a player's team space control efficiency will drop by 12% in the final 20 minutes based on historical time series data, what happens?
The analyst tells the coach?
Right. Does the performance analyst tell the coach to substitute them regardless of how they actually look and feel on the pitch?
If the predictive model is highly accurate, yes. Because human eyes get tired and coaches suffer from recency bias.
But what about the ethics of treating human athletes like autonomous vehicles generating telemetry data? The review briefly but importantly calls out the need for ethical regulation.
I agree. Regulation is needed.
When a player transfers to a new club, does their historical deep learning profile follow them? Does a black box algorithm prejudice their new manager before they even step on the grass? We are making massive assumptions about human beings without comprehensive guidelines protecting their autonomy. A player has absolutely no way to argue against an algorithm they don't even understand.
I definitely acknowledge the friction there, and the ethical parameters absolutely need to be formalized, just like in any industry adopting artificial intelligence.
Glad we agree on that.
But the existence of a learning curve, whether that means figuring out data privacy frameworks or teaching traditional coaches how to read an expected possession value metric, does not negate the revolution itself. It just defines the next frontier.
The frontier's messy.
When this review talks about a new era of understanding, it's pointing out that we can analyze pass effectiveness without the cognitive biases that plague human scouting. Let's be honest, coaches have favorites, coaches have blind spots.
True.
An artificial neural network, properly trained, does not care about the narrative. It only cares about the spatio-temporal reality. That objectivity actually protects a player from a coach's subjective biases.
That assumes the data model itself is completely free of bias, which any computer scientist will tell you is an incredibly dangerous assumption.
How so? The tracking data is just neutral geometry.
The geometry is neutral, but the model decides what to value based on how it was trained by human engineers. If a performance analyst trains an algorithm to prioritize high possession retention, it will inherently undervalue a highly creative, high-risk player.
The playmaker dilemma.
Think about your favorite visionary playmaker in the midfield, the player who attempts incredibly difficult, defense-splitting passes that frequently get intercepted.
A high-risk, high-reward profile.
Exactly. The algorithm will look at their pass completion rate, calculate a low expected possession value over time, and tell the coach to drop the player because they are technically inefficient.
But wait,
But the coach, relying on human intuition and deep football knowledge, knows that just one successful pass from that player can win the entire match. The ethical limit of data analysis isn't just about data privacy. It is about the algorithmic homogenization of a beautifully asymmetric sport. It forces everyone to play efficiently according to the narrow parameters of a machine.
that is a very compelling argument, but let me give you a different perspective on the machine's capabilities. The AI isn't homogenizing the sport. It is actually revealing the vast, unexploited tactical landscapes within it. We are moving beyond those simplistic metrics like pass completion percentages, precisely because AI allows us to contextualize risk in ways we never could before.
Contextualize it how?
Through advanced models like the pass probability model combined with a dangerosity assessment.
Dangerosity.
Yeah, to explain that simply, the algorithm knows the difference between a safe, boring sideways pass and a high-risk through ball. The machine learning model actually rewards the high-risk pass. if the potential pitch control gained justifies the attempt.
Really?
Yes, it doesn't punish the playmaker for trying something difficult. It accurately quantifies their tactical genius. The 32 studies synthesized in this review demonstrate that we finally have the mathematical vocabulary to capture complex tactical strategic thinking. It allows coaches to design training routines that directly replicate the most complex, high-value scenarios identified by the algorithm.
Well, I will concede that the mathematical vocabulary is expanding rapidly. The ability to quantify the danger or value of a specific pass is an incredible leap forward.
It changes everything.
But we have to respect the literature's own limitations. The reason those 32 studies are so crucial is because they represent the bleeding edge of what is theoretically possible in AI. They do not represent what is currently practical in the chaotic ecosystem of professional football.
But the trajectory is permanently set.
Perhaps the trajectory is set, but until we bridge the gap between the data analysts staring at a beautifully clustered dimensionality map and the coach trying to motivate 11 exhausted human beings on a rainy Tuesday night, we are just analyzing mathematical approximations of football. We cannot ignore the ethical and practical roadblocks standing between these brilliant theoretical algorithms and real-world application.
To a close, my position remains firm. The synthesis of deep learning, machine learning, and continuous spatial temporal tracking data has irrefutably elevated match analysis. We aren't just guessing based on a manager's gut feeling anymore.
Right.
The ability to predict performance, assess team formation patterns dynamically, and design training tasks based on objective AI-driven tactical behavior mapping is not a passing trend. It is a permanent evolution. We have fundamentally shifted from subjective observation to a rigorous, highly intelligent data analytics era.
And I maintain that while this systematic review showcases an incredible leap in computer science capabilities, we must look at the reality of those stringent filters. Leaving only 32 studies from a massive pool of over 2,500 proofs, we are still dealing with highly sanitized retrospective models.
The true challenge of the next decade will not be writing better code. It will be synthesizing raw data analytics with human coaching expertise. We have to build the ethical frameworks necessary to protect the human beings generating this data, ensuring we don't reduce brilliant athletes to mere algorithmic outputs.
It seems we are both looking at the exact same pitch, just through entirely different lenses. Artificial intelligence provides the structural blueprint, revealing the complex, fluid dynamics of tactical behavior in ways we never thought possible.
True. The models help us see the hidden mathematical currents with incredible precision. But at the end of the day, someone still has to interpret those currents, and you simply cannot code human empathy or the sheer will to win.
A fascinating intersection of human intuition and artificial intelligence. The translation of big data into on-pitch reality is an ongoing, highly complex evolution, and it certainly warrants our continued observation. Thank you for joining us, and we'll leave you to consider where the data ends and the human begins.